Hello, everybody. It's Brian David Johnson. I am the guest editor of the IEEE Computer Magazine issue on the world of making. And to pull together this issue, we reached out to a lot of different people all over the world, people who are doing work in biology, design, science, business, technology, entertainment, education, and culture. And the goal was really to get a snapshot of the world of making in the year 2014. So today on the podcast, we're really fortunate to have AnnMarie Thomas joining us. She is an associate professor of engineering at the University of St. Thomas. AnnMarie, thank you so much for joining us today.
Oh, thanks for having me.
So AnnMarie, let's start off by talking a little bit about your background and also how you came to making.
Sure. So I think almost all kids, was always the kid who wanted to mess around with things and see how things worked. And I was particularly drawn to things like the arts and a little bit to mechanical woodworking and such, but lots of theater and clothing and sewing, and really actually oil painting quite a bit, and realized that to me engineering was the way to do those things as a career. So was fortunate enough to go to a school that let me kind of dabble in that sort of thing. I went to MIT, where I was an ocean engineer, but I still did some music and other artistic endeavors, and then on to do graduate work in California, where at night I used to sneak off to an art school, first as a student, then as a teacher. And so I think for me, I've always been immersed in the world of creating things and taking ideas and bringing them to life.
And so for a lot of people, there's this idea that creativity and engineering, or creativity and science, are these two parts of the brain that never shall meet. What do you think about that?
It's funny, I was talking to a couple hundred high school students last week about this, and I said, my college application essays, I said that I wanted to be an engineer because I had always wanted to be an actress. And to me, growing up, I did a lot of theater. And in theater, someone tells me what to say and what to wear and where to do it and where to stand and, where the light would be. But I saw engineering as a way that I could really come up with, things that had never been done before and, really embrace that as an artistic outlet. Especially with my students and my own kids, I really see engineering as taking all these tools, be they drawing or math or physics, and using them to create, brand new things. And that's an inherently creative activity.
Yeah, I think it's an awful and actually sometimes dangerous misconception that for some reason engineering is not creative, and for some reason that doing the arts or design is not technical. Because some of the most creative people I know are engineers, and some of the most technical people I know are artists. And I also think it can have dangerous effects when kids, like you said, are starting to make decisions about what they're interested in and how they might do things if they think that one is sort of exclusive of the other. But AnnMarie, I wanted to find out a little bit more about what you're working on and what you're making.
Sure. So at the University of St. Thomas, I'm an engineering professor. I also run our Center for Engineering Education, so I have the great honor of spending a lot of my time with K-12 teachers, but then also first-year engineering students. And my research these days, it wavered through things like robotics and other things throughout my career and my doctorate, but these days I spend my time looking at play and how we can use play to teach and how we can learn through play. So things like censoring up my students and putting them on the flying trapeze to teach about pendulums, or in the case of probably our most popular project in sort of the maker vein, how can we sculpt circuitry? So a few years ago, a first-year engineering student and I decided that some people paint circuits and some people sew circuits, and we wanted to be able to sculpt working circuits. So we developed something called squishy circuits, which is a homemade set of recipes for conductive Play-Doh and insulating Play-Doh, so that you can actually sculpt circuits that then, when you plug a battery pack into them, they light up, or they make noise, or they even start a motor spinning.
And so what have you seen as you, I love the notion of squishy circuits, as you've taken squishy circuits out and literally put them into the hands of teachers and put them into the hands of kids, what's happened? What have you seen?
We've seen awesome things because we never set out trying to tell anyone how to use it. We purposely put it on our website and put all the recipes and put all the instructions for how to build the parts yourself and made it so you never even had to tell us that you were doing it. And the neat thing was people did start telling us what they were doing with it, and we started hearing about preschool teachers who were dyeing the conductive dough green and the somewhat insulating dough red, or we heard about schools in Iran that were using it and doing interesting projects. So it was really interesting to us is to see that we could come up with the recipes, but we weren't as good as coming up with exactly how to use it. And that wasn't our goal. We didn't want to prescribe for anyone how to use it. To me, that's a big part of the maker movement is this sense of sharing and throwing things out there. And every morning I do tech support. Today I had a fourth grader, good luck on your science project, Ellie, and I also had a teacher emailing to ask me questions about Squishy Circuit. And we answer them, but we never tell them what to do. And for us, that's the fun part, is seeing what they do.
Yeah, and I think in so many, certainly in the article that you wrote and a lot of the contributors, that making, sort of the concept of making is about platforms and about tools and about putting these platforms and tools into the hands of whether they be young minds or maybe some gray-haired minds as well, but giving people the tools and the platform then to be able to make and create on their own. And I wanted to ask, so where do you think all this leads? What is your hope? First, with Squishy Circuits, certainly, but also, what is your hope with making in general as you look at the intersection of play and engineering and design and creativity? Where do you think it all could lead us?
Well, for Squishy Circuits, I think my greatest hope for it is that people keep doing it and that I don't hear everything they do with it, that it just becomes one more way that people play with the things around them. And once in a while I get to peek into that world, and it's fun to see what's happening. But I hope it instills in someone the confidence. I hear from parents sometimes who say they've never used electronics with their kids, but they felt like they could do that. And those are some of the best emails. In terms of play, I agree with you. I think it's about tools and platforms, but more than anything, I think actually the maker movement is about this concept of community and being willing to learn things at any age. You mentioned the young kids, but also kind of the gray-haired folks. And I think to me that's the beauty of it. It's really saying we can jump in, we can learn things, we can ask our neighbors, or we can ask our neighbors online who might be nowhere near us how to do these things. So to me, I think the end goal here is that everyone can see themselves as capable of learning new skills and capable of creating things, that it's not just the experts, the people who went to school for many years who can do these things. Anyone could start learning how to create something. And it might not be as great, as someone else's. It's not necessarily Dale Doherty, who founded Make, once told me it's not about professional development, it's about amateur development. And I think that sums it up, the sense that we all could try these things. And particularly with a community where people are willing to help you, whether in person at a community makerspace or even a neighborhood sewing circle, or online through a project sharing platform.
Yeah, there's a gentleman by the name of Jay Silver, and I worked with Jay for a number of years, and he is the inventor of Makey Makey, which is another. And
Jay is a dear friend who I'm having coffee with tomorrow. So makers are interconnected.
Because Jay, so for everybody who's listening, so for Jay created this platform that allowed basically anybody to make an interface out of anything, to interface with a computer. So, he famously made a piano out of bananas, and he's made lots of really fascinating things. But Jay gave this great talk once where he talked about, as a designer and a builder and a maker, that for many years he had been striving to make the best thing, right? The best product design, the best thing. And I think for myself and for a lot of people who've sort of come to making, we all kind of shared that. It's that we want to make the best thing ever. But then you realize that it's not about that making the best product or making the best robot or the best computer ever, it doesn't work, because meaning everybody is different. You can't make one perfect product. That everybody is so different that you shouldn't focus on making one perfect thing. You should make a platform so people can make 7 billion perfect things, or make 14 billion because they want to make 2 perfect things. And that really, for me, as I think about that if you think people are making, one product that is supposed to be the best product ever, it's almost tyranny, that you're forcing people to take this one product and only do that one thing with it, and that by creating these platforms like Squishy Circuits and like Makey Makey, that we really are allowing people to make 7 billion or 14 billion of the best things ever. And I think that really kind of encapsulates even kind of what you're saying, is that it really is about a community of people getting together, making the best things ever, sharing them, so that then other people can take them, and then they could go make the best thing ever. So I think it's just a beautiful, beautiful vision. And also I just love Squishy Circuits as well.
I'm probably the only engineering professor in the U.S. or world who's tenured on Play-Doh.
Right.
Take joy in that.
Well, AnnMarie, listen, I want to thank you so much for joining us on the podcast and also for your great contribution to the issue. If the listeners want more information about squishy circuits or the work that you're doing, where should they go to?
Sure. So for squishy circuits, probably your best bet is just to Google squishy circuits, and you'll go to the first link hit you get will probably be our university page on squishy circuits for all of the videos and all the recipes and all the how-tos are there. And then for my own work, I would say, I just spend a lot of time interviewing makers about their childhood. So the best way to find me and my contact information is to go to makingmakersbook.com. And you'll find me there, and I'd be happy to answer any questions anyone sends, squishy circuits or otherwise.
Awesome. Well, AnnMarie, thank you so much for coming on the podcast. Give my best to my buddy Jay Silver, but thank you so much for joining us today.
Thanks for having me.